texture mode is one of the 6 audio sample warping modes in Ableton Live. Conventionally speaking, warping is used to keep audio samples in time with a project's BPM. If an audio clip's BPM is different than the project BPM, Live will use the designated warp mode to stretch or compress the clip's audio accordingly in time with the project. However, if we stretch the audio to extreme lengths, we can abuse Live's warp modes to create interesting results. Each mode begins to reveal the distinct sonic characteristics baked into its algorithm, becoming more pronounced as the audio is stretched further. Texture mode produces particularly compelling results when it comes to the practice of drastic audio warping. It is also the focal point of this video. Through texture mode, we will demonstrate the third method for creating exponential rhythms in Ableton Live. Audio warping in texture mode allows us to create exponential rhythms in a distinctive way, quite unlike the 2 methods we've previously demonstrated. The first key difference has less to do with the resulting sounds, and more to do with the process itself. When using texture mode, exponential rhythms can be achieved strictly on an audio sample level, without the help of any instruments or additional effects. The procedure is quick and straightforward, and only requires the knowledge of a few key concepts and parameters. The first of which we will refer to as creating exponential rhythms with Ableton's arpeggiator, or simpler, is predicated on the repetition of the same event. Whether it's the generation of several MIDI notes, or continuously looping a sample. If we forego pitch and amplitude modulation, our rhythms become sequences of identical transients. Once stretching warped audio, on the other hand, our exponential rhythms evolve over time, following the contour of a sample's inflections in pitch, timbre, and amplitude. We can control the extent of this effect by increasing an audio clip's segment BPM value, either by dragging, typing, or clicking the BPM doubling button. The greater the difference between the segment and project BPM, the more drastic the result. Let's demonstrate with this percussive loop. When we use texture mode, we gain 2 parameters, grain size and flux. When warping an audio clip, texture mode breaks the sample down into small, discrete snippets of audio, or grains. Grain size determines the length of these grains, which in turn determine the rate of our exponential rhythms. This parameter boasts a wide range of operation, capable of producing grains that are extremely short, audio rate length, to ones that are fairly long and individually distinguishable. introduces a new element into the synthesis of exponential rhythms, one that we have not yet explored in the previous videos in this series: the element of rhythmic jitter. Flux applies a random amount of length variation to each grain produced, with lower values adding subtle rhythmic variation, and higher values creating significant rhythmic stutters. Grain size and flux are pitch dependent, so transposing the sample will proportionately affect the length of each grain. As a result, we gain another approach for creating exponential rhythms, by modulating pitch, instead of modulating grain size. We'll demonstrate with this drum loop. Unfortunately, sample warping parameters aren't available in track automation lanes like most other things. Warping is done on an audio clip level, which means that warp parameter automation must be performed on the same level, through the Envelopes tab in the Sample Editor window. Creating automation in this tab is almost identical to doing so in the Arrangement window, but a very important thing to note is that we are not automating parameter values. We are automating percentages, where the maximum value is the current value set in the Audio tab. As a rule of thumb, we always set the grain size and flux parameters to their maximum values to ensure that we have a full range of modulation in the Envelopes tab. With the power of clip automation, we can contour our exponential rhythms with a greater degree of nuance and precision. By exploring the interdependence between the grain size, flux, and transpose parameters, as well as choosing from various types of source material, we can design an incredible range of evolving rhythms and textures. Let's demonstrate with this click sample. We can combine a small grain size value with a high flux value to introduce a noisy timbre to our results, while still preserving the transient contours of the original sample. When we combine large grain size and flux values with a sample that's pitched up, we spread and smear the transients over time to create jittery rhythmic textures. By utilizing the clip's automation lanes, we can blend between both of these textural extremes, as well as any other combinations that you discover on your own. It's also worth experimenting with reverse samples. Inverted pitch and transient information can lead to interesting sonic territory. Let's use this kick for example. Layering audio effects on top of warped material will add extra levels of depth to your sound design sessions. Now that we've acquired proficiency with texture mode, we can direct these techniques towards more specific applications, such as pitch sampling, stretchless warping, flux panning, automation looping, and warp recursion. If you are keen on mastering these topics, we will explore each of them in depth next week, when we release this Patreon exclusive video.